Hello guys, we want to start our second lecture of chapter 12. So in this lecture, I want to talk about normal function and then I want to talk about orthonormal set. In the last lecture, I talked about normal vectors. So we said if we have a vector like u and if I want to find normal vector u, so we can find it by this equation. So it's equal to root of inner product of u and u. We have the same definition for norm of a function. If you have a function like phi and x, and if you want to find its normal function, so it's equal to root of inner product of phi n x and phi n x. And in the last lecture, we defined inner product of two functions as well. So let's solve one example. We want to find norm of, in this example, you want to find norm of each function in the set of function of cosine x, cosine 3x, cosine 5x, and so on interval 0 to pi over 2. In the last lecture, we found that this set of function is orthogonal function. Now we want to find norm of each function in this set. In fact, we have to find norm of cosine x, norm of cosine 3x, norm of cosine 5x, and so on. So we cannot find them individually. As a result, at first, I write this set of function in a compact form. So I say norm of cosine x, cosine 3x, cosine 5x, and so on. It's equal to cosine 2n minus 1 times x, and n is equal to 1, 2, 3, and so on. And I find norm of cosine 2n minus 1x. So if you want to find it, so in fact, norm of cosine 2n minus 1 x based on definition, it's equal to root of cosine 2n minus 1x and cosine 2n minus 1x. So norm of this function is root of inner product of these two functions. We have to find inner product of cosine 2n minus 1x and cosine 2n minus 1x. So if you want to find it, it's equal to so we have root the integral from 0 to pi over 2, because we want to find normal function in the range of 0 to pi over 2. First function is cosine 2n minus 1 times x, and second function is the same. As a result, is cosine squared dx. So we know that, so I say note cosine squared theta is equal to half 1 plus cosine 2 theta. As a result, normal function is equal to root of half the integral from 0 to pi over 2 1 plus cosine 2 theta. So here theta is 2n minus 1. So it's 2 times 2n minus 1 times x dx. It's equal to root. So half integral from 0 to pi over 2 dx plus half integral from 0 to pi over 2 cosine 2 times 2n minus 1 times x dx. It's equal to so half integral of dx is x from 0 to pi over 2 plus half integral of cosine 2 times 2n minus 1 x. It's equal to 1 over 2 times 2n minus 1 sine 2 times 2n minus 1 x. And I have to apply the upper limit, lower limit. So it's from 0 to pi over 2. So it's equal to root we have half. So if I apply upper limit here, we have pi over 2 minus 0. So it's pi over 2 plus half. So here in the second term, if I apply upper limit, so we have x is pi over 2. So we have 2 here. 2 times pi over 2 is going to be pi. Pi times integer number. So sine of pi times integer number is equal to 0. If I apply lower limit, so we have sine 0 is equal to 0. As a result, this term is equal to 0 times 0. So it's equal to root pi over 2. So we could find norm of any function in the given set. Now I want to talk about orthonormal set. If a set of phi n x is an orthogonal set of function on the interval a to b with the property that norm of phi n x is equal to 1 for n equal to 1, 2, 3, and so on, then set of phi n x is said to be an orthonormal set of the interval on the range of a and b. So in fact, you have to have one orthogonal set, and norm of each function in your set should be equal to 1 if you want to have one orthonormal set. In general, any set of non-zero functions like set of phi n x for n equal to 1, 2, 3, and so on can be normalized by dividing each function by its norm. For example, in this example, you want to normalize following set of function on the range of 0 to pi over 2. So the set of function has 3 functions. So it's x, sine x, and cosine x. So this set is not orthonormal because norm of each function is not equal to 1. If you want to normalize it, we have to find norm of each function, and then we have to divide that function by its norm. So first we find norm of x. If you want to find norm of x based on definition, it's equal to root of inner product of x and x. It's equal to root integral from 0 to pi over 2. First function is x times second function is x, so it's x squared dx. If you find this integral, so it's going to be root pi to the power of 3 divided by 24. Now I have to find norm of the second function. Second function is sine x, so I have to find norm of sine x. It's equal to root of inner product of sine x and sine x. It's equal to root integral from 0 to pi over 2 sine x times sine x, so sine x squared dx. If you find this integral, you can see that it's equal to root pi over 4. And if I find norm of the third function, so it's cosine x, so it's equal to root of norm of cosine x and cosine x. It's equal to root integral from 0 to pi over 2 cosine squared x dx. So if you find this integral, you can see that it's equal to root pi over 2, pi over 4. So now we have norm of each function in the set. If you want to normalize this set of function, I have to divide each function by its norm. So as a result, I divide x by its norm, which is root pi cube over 24 sine x divided by its norm, which is root pi over 4, and cosine x divided by its root, which is root pi over 4. So now this set of function is a normal set of function. It's not orthogonal, but it's a normal set of function. Now we go to solve another example. Consider the set of functions. So it has two functions. A is a constant function and bx plus c, where a, b, and c are constants. These are two polynomials from set of continuous functions on the interval of 0 to 1. Find the values of a, b, and c that makes the set orthonormal. If you want to have this set orthonormal, first this set should be orthogonal, and then norm of each function should be equal to 1. So if you want to have orthogonal set of function based on definition, inner product of functions so should be equal to 0. So in fact, the inner product of a and bx plus c should be equal to 0 if you want to have orthogonal set. So based on definition, we have the integral from 0 to 1 a times bx plus c dx should be equal to 0. As a result, a times bx squared divided by 2 plus cx from 0 to 1 should be equal to 0. So it means that a times b over 2 plus c should be equal to 0. If a times b over 2 plus c is equal to 0, a should be equal to 0, or b over 2 plus c should be equal to 0. So it means that b should be equal to minus 2c. So It's for orthogonality of this set of functions. Now we have to check if norm of how norm of each function is equal to 1. So in fact, if you want to have an orthonormal set of function, norm of each function should be equal to 1. At first, I find norm of a. Norm of a should be equal to 1. If norm of a is equal to 1, norm of a squared is equal to 1 as well. As a result, the integral from 0 to 1, a times a, so it's a squared dx, should be equal to 1. So it means that a2 times x from 0 to 1, it's equal to 1. So a squared should be equal to 1. If a squared is equal to 1, so it means that a can be equal to plus 1 or can be equal to minus 1. If norm of a wants to be equal to 1, a should be 1 or minus 1. As a result, here in the first part we said a can be equal to 0. It's not valid because a should be equal to 1 or minus 1. If a is equal to 0, norm of a cannot be equal to 1. Now we have to find norm of second function. So I find norm of bx plus c, and it should be equal to 1. As a result, I can square. So I can say that norm of bx plus c squared should be equal to 1. I square both sides of the equation. So it means that the integral from 0 to 1, bx plus c times bx plus c, so it's bx plus c squared dx, is equal to 1. Now I find bx plus c squared. So we have the integral from 0 to 1, b squared x squared plus 2bcx plus c squared dx should be equal to 1. So it means that b squared x cubed divided by 3 plus bc x squared plus c squared times x. So from 0 to 1 should be equal to 1. As a result, if I apply upper limit and lower limit, so we have b squared divided by 3 plus bc plus c squared should be equal to 1. From orthogonality of this set of function, here we found that b should be equal to minus 2c because in fact we said if you want to have one orthogonal set of function, a times b over 2 plus c should be equal to 0. So we said a should be equal to 0 or b over 2 plus c should be equal to 0. Then we said based on norm of a, so because you want to have norm of a equal to 1, a cannot be equal to 0. As a result, b should be equal to minus 2c. So in this equation, I assume that b is equal to 2c. It's minus 2c. So we're gonna have a minus 2c squared divided by 3 plus minus 2c times c plus c squared is equal to 1. So it means that c squared should be equal to 3. And as a result, c can be root 3 and minus root 3. So we said b is equal to minus 2c. As a result, b can be equal to minus 2 root 3 and plus 2 root 3. So we found two values for a. A can be equal to 1 and minus 1. Two values for b. B can be equal to minus 2 root 3 and 2 root 3. And c can be equal to root 3 and minus root 3. As a result, we have 6 answers for these 3 constants. So in fact, a, b, and c can be equal to 1 minus root 3 minus 2 root 3 and root 3. It's what one set of solution. It can be equal to 1 2 root 3 and minus root 3. Second one. The third one, a can be equal to minus 1, 2 can be equal to minus 2 root 3, and c equal to root 3. And the fourth one, a can be minus 1, 2 can be equal to 2 root 3, and c minus root 3.